13 species of finches inhabit the Galapagos Islands, and they vary subtly in terms of their body size and shape of the beak. Darwin returned to England with 9 different species of these birds.
According to contemporary Darwinian theory, differences in the sizes and shapes of the birds' beaks are the direct result of natural selection. One example often cited involves species of seed-eating finches. Following seasons of heavy rain, small, soft seeds are plentiful throughout the islands. Birds with short beaks can easily gather food. However, during periods of drought, the only seeds available are encased in hard, tough shells that remain on the ground from the previous year. In these circumstances, only birds with longer, sharper beaks can crack the shells and eat the seeds.
Those birds with the longer beaks survive because they can reach the food source, whereas other birds cannot. That long beak, then, confers what biologists now call a functional advantage. The finches with smaller beaks, unfortunately, die out from starvation because they cannot reach that food source. If the drought conditions continue, the environment causes a change in the features of the finch population as a whole. Over time, the long beaks are passed on to succeeding generations because those beaks enable the birds to survive.
Natural selection was a powerful idea. Physical variations that proved advantageous would be inherited by succeeding generations. Through this process, populations would be altered, and over time, fundamentally different organisms would arise without any form of intelligent guidance.
Darwin wanted to explain everything in the history of life in terms of undesigned, unintelligent natural processes. And when he looked for an explanation, what he found was that a process he could observe in domestic populations also operates in the wild. Now, Darwin himself was very familiar with domestic breeding. He himself studied pigeon breeding. And he knew that for centuries, human breeders had been able to make dramatic changes in populations by selecting only certain individuals to breed. Darwin really suggested that this same process operates in the wild.
For Charles Darwin, natural selection explained the appearance of design without a designer. There was no longer any need to invoke an intelligent cause for the complexity of life. In effect, natural selection became a kind of designer substitute.
Today, Darwinism is generally assumed throughout science and the academic world. Yet, despite its wide acceptance, a growing number of scientists and scholars, including those who met at Pajaro Dunes, now challenge key aspects of Darwinian theory.
When we came together at Pajaro Dunes, we certainly didn't agree on everything, but we did share a real dissatisfaction with the mechanism of natural selection and the role that it was playing in biological explanation. Natural selection is a real process, and it works well for explaining certain limited kinds of variation, small-scale change. We have lots of examples of that, in fact. Where it doesn't work well is explaining what Darwin thought it could, namely the real complexity of life. We have a finch beak, and then you've got the finch itself. A minor change in the structure of the beak versus the origin of the organism itself. These are different scales of phenomena. These are different kinds of problems. And the important problem for biology is to understand where natural selection works and where it doesn't, and why there's a difference. Evidence is very powerful, and all of us had the sense that if we let that evidence speak for itself, that it would lead us in a very different direction, away from natural selection and towards a different conclusion about the origin and nature of life on Earth.
Natural selection acts only by taking advantage of slight successive variations. She can never take a great and sudden leap, but must advance by short and sure, though slow steps.
It's really interesting to notice that the more we know about life and the more we know about biology, the more problems Darwinism has and the more design becomes apparent.
Since 1988, Dr. Michael B. has investigated complex biological systems that seem to defy explanation by natural selection.
For the longest time, I believed that Darwinian evolution explained what we saw in biology, not because I saw how it could actually explain it, but because I was told that it did explain it. In schools, I was taught Darwinian biology. And through college and graduate school, I was in an atmosphere which just assumed that Darwinian evolution explained biology. And again, I didn't have any reason to doubt it. It wasn't until about 10 years or more ago that I read a book called Evolution: A Theory in Crisis by a geneticist by the name of Michael Denton, an Australian. And he put forward a lot of scientific arguments against Darwinian theory that I had never heard before. And the arguments seemed pretty convincing. And at that point, I started to get a bit angry because I thought I was being led down the primrose path. Here were a number of very good arguments, and I had gone through a doctoral program in biochemistry, became a faculty member, and I had never even heard of these things.